In this video, let's use the following information to quickly calculate a z-test statistic, a p-value, and state whether or not we should reject the null hypothesis based upon our significance level. The first thing is we should calculate our z-test statistic. So this is equal to z of x bar minus mu naught all over sigma over the square root of n. This is then equal to 14 minus 12, our claim, divided by the population standard deviation of 7 over the square root of our sample size 30. This will be equal to a numerator value of 2 and a denominator value of 1.278. This is then, of course, all equal to 1.56, and I've just rounded it to the hundredths place so that I can look this up on my table. I'm going to first draw my distribution, though, because what I'm looking up is a z-test statistic. And so I want to find a two-sided test because my alternative is two-sided, which means I need to find the area that falls above my test statistic of 1.56 and below the test statistic when it's negative, so negative 1.56. This will give me my p-value, my two-sided p-value. So when I look up on the table, I can look up negative 1.56. So if I scroll down, I start and I see negative 1.5, and I scroll over to the sixth column, and that is this one here. So I get 0.05938 for the area that falls below a z-test statistic of negative 1.56. So again, this is equal to 0.05938 according to our table. Well, one really cool thing about a two-sided test and the standard normal distribution, or standard normal table, is that the area that falls above 1.56 is the exact same area that falls below a negative 1.56 because of symmetry. So up here we have 0.05938. So if we just add these together, or essentially just multiply one of these by 2, we'll get our two-sided p-value. So in this case, our p-value is equal to 0.11876. That's, again, just adding these two values together. So what does this mean? This means that we will fail to reject the null hypothesis. Why? Because our significance level of 0.10 is less than our p-value of 0.1876. And our p-value must be smaller than our significance level in order to reject. Since our p-value is larger, we fail to reject.